So this discussion are about contour. So initially, if you want to generate contour, just like if you want to, maybe in any other mathematical software, you just need the x, the y, and then the z. But here, because of the kind of complexity of the kind of what we are dealing with, so you actually need more than that. So because we have faults, so you have to come with the information about the faults and other stuff like that. So the one that the algorithm uses, that we use in the software, is this guy, this other one here. So because you send the geosurface, which is that horizon, and then the contour levels that you want to generate. So exactly, so that's what you send. So when you send that, then we'll now generate that contour, but we still need to do some other things. Yeah. So what we just discussed now is the process of generating the contour, which is basically three things. So I run these three things here. The con, then the form part, and the joint continuous part. So that is, and then if there is faults, I'll run this joint to faults. So, but since for about 3 days now, I've been thinking about how to make modification for this guy, the joint to faults stuff. I've been thinking about how to make modifications to it. So, it is likely that I will make a modification that will revert to one old style that we're using, because that method is simple and it is foolproof. So it's likely that that is the method that I will go back to. There is something again that I need to say. Okay, so I think we'll go back to that and then we will do the implementation together.
Okay.
All right. Yeah, we'll do that today. So because that our old method is kind of reliable and better than whatever as in we have before. It is the old method too, but because of the kind of data that we have, sometimes they can send data and there is no Z value for the faults. So that's created a problem. And in order to manage that, we try to create other kind of problems, other kind of methods. So for those methods are actually, as in you are not supposed to be trying to solve that kind of a situation where they give fault polygon that does not have Z. So what we should do is to calculate the Z and then use it. So I want to revert to the old method that assume that there is a Z. So in fact, if there is no Z, I have another algorithm that you can send the fault polygons to that will calculate the Z for them. So which means that we can write our joint to faults with the mindset that there will always be Z values for the fault polygons. Because for the fault polygons. So because that's how it's supposed to be. So we'll make a correction, we'll change this guy because the current algorithm is long.
Sorry, let me ask one question. So from the data that comes from wherever it's coming from, does it include the fault polygon data? Because I know we calculated that fault polygon ourselves.
No, I can calculate fault polygon, but tell I can calculate fault polygon.
So if we calculate the fault polygon, why do we need that data again?
No, if I calculate the fault polygon, there is Z there now. My fault polygon will have Z. So this algorithm now, we change it to use the Z, not to extrapolate to shoot to the distance. I'll just use the Z to join it.
So that means we don't need bother since we calculate them ourselves.
You see?
That means we don't go need bother since we calculate them ourselves.
Yes, now. So that's not an issue. So we're fine. So let's just go through these three guys and then what they do. So for this particular stuff, Latoke by from here down here. Okay, sorry, Mofele is shaking it. Mofele testing up also. Let me remove this guy. So from here down here is just extracting all the data that I need. All right, so the calculation starts from just these 4 lines. That's when, or 5 line, that's when the calculation happens. So the first thing is I have what I call list of curves. I call paths. So why list of curves? Let me explain. So let's say I want to generate a contour for 10 levels. So the first list will contain 10 items. Then inside each list, so you contain, because I want 10 levels, so it will contain 10 items, each of them belonging to each level. Then when you're now going to each of those items can have any number of elements inside it. I don't know any number it will have, right? So some may be empty. Maybe the surface you are trying to calculate the contour for does not intersect that particular level. If, let's say, the maximum value on the surface is maybe 200, and then you are trying to calculate a particular level that is around 250. That is something higher than the maximum that you have there. So that list that belongs to that contour level 250 will be empty because there will be nothing inside, since the surface does not intersect that. Why now? Go and play with your mommy now. Why are you crying? What do you want? Yeah, sorry. Sorry. Go and do my lip. Okay, you deal with me?
Mm-hmm.
So I say if we get like 10, if I'm sending 10 contour levels that I want to draw the contour, and one of them has 250 in it, and the maximum value I have on the surface is 200. That means that particular list or item that belongs to the contour level 250 will be empty.
Yeah.
All right. So now, so let me now show you what I did, how I implemented it. So we will come back to all these guys, this picture. So now, when you send the data, when the data comes into our algorithm, we run some calculations that create the geosurface, and then we try to store all the data in terms of primitives, so that we can easily read them. So that is handled by Carl. So, but when you want to do any other calculation, and those data come from the primitive and repopulate everything that is inside the geosurface. So those things, this is everything that is repopulated. So I am now taking them, I'm extracting the things that I need from the geosurface. This is the geosurface that was sent here. All right. So I'm taking all the things that I need to calculate my contour from the geosurface. So the DD full, I don't need DD full, I just anyway. So X, Y, I just bring everything. So after that, the next thing is I calculate the contour here.
Okay.
But the contour I'm calculating here, pay attention. I am calculating small lines, bit by bit. After calculating all of them, what I do is I now combine them to form curves. That's what I call this one form paths. So,
okay.
So then after I form all those curves, there are some curves that they are supposed to be joined together, but they are not joined together. All right. So I try to find those curves and then join them together also. So then I now have join continuous path. So let me now take you to this guy. So now this path that I created here, so that's the one that we'll use this guy. So there's another one. So there's another one that I call path line. You can see this one. Okay. So now this one will be created inside this con. So let's open that con. So okay, now you see the path line there.
Yeah.
All right. So I go into this one by one, and I add a list of lines inside. So as I'm doing my calculation, I'm creating lines. So let me try to draw a diagram to show you what I'm trying to do. So, okay, I can use, okay, let me use Excel. You did it, Ahmed.
Yeah, I did.
Okay. Okay, now. So let us assume that we have this grid as it like this now.
Okay.
And I am trying to, I don't know if I can write something. So I'm trying to calculate create a contour. So let us now focus on this particular grid. So let's say the level here is 50. I don't know if I can write here. Okay. So no, I can't write them. Just waiting. Okay. So let's say we have this. I want to focus on this grid. Sorry, with some of people saw this. So let's say here is 50. Let's say here is 60. Sorry, I look at and then let's see. Yes, 65. And let's say here is 40. Now, you been know how to draw contour before, Abi?
I never drawn contour before.
You see?
I never drawn before.
Okay. Let's see. I'll show you now. So let's say I'm trying to draw the contour line of line 55. All right, of level 55. Sorry, this level now 50. Having this point here, then this point now 60. This point now 65. This point now 40. Now 55. They between, as in, if you pick these numbers, these two, if you pick any two of these numbers combined together, now which pair you go talk say 55 fall in between?
Sorry, if I pick any number between
if
what?
I pick any two of these numbers, any two, you understand together. Which two where you go pick? You go tell me say 55 fall in between.
50, 60, and 50, 65.
What about 40, 65?
40, 65 and 40, 62. Sorry.
Oh, okay, good. That makes sense. So now, that means our job now is to figure out how the level 55 pass inside this particular square.
Okay.
Or this rectangle. So the first thing we will do now to find, okay, say
sorry, make I ask, this level now, what's in big on go for inside data? Now XYZ or something, I don't understand.
No, all these things why I show here now just the Z level. I don't show the XY.
Okay, now the Z level.
But now the Z for this one, because the XY they already fixed by this line, the grid line I draw.
Exactly. Yeah.
So that just the Z there. So now, so it means that 55 they halfway between 60 and 50.
Mm-hmm.
Which means the line will pass just midway somewhere here.
Yeah.
Now the line will go pass between 60 and 65.
Of course.
But it go pass between 65 and 42.
Mm-hmm.
So and 55 now like 2/3 of the way between 3/5 of the way between 40 and 65. 3/5 of that distance. Like you know say 55 from 40, that gap now 15. 65 from 40 now 25.
Mm-hmm.
So which means that will be 0.6 of the distance between 40 and 65 from 40.
Yeah.
So you go there somewhere here like 60% from 40. So somewhere here like this. Abi?
Mm-hmm.
So now, but we don't know how the line go, whether it goes straight like this to this point. We don't know if it go anyway. But the easiest way to generate contour is not consider the center. Just consider this square as a whole like this. So just like the way I did now. So I will just join this part. So as I get this point and I get this point now, I will use these 2 points form a line.
Okay.
You understand? Keep them somewhere. So collect all those lines like that. Use them form curve.
So make I ask you one question. Very quickly. You know, say we go see the same 55 between 40 and 60. So
yeah.
That means say now 3 lines down go be, but we don't need the third line. So now only 2. No, we don't need the third point. So now only 2 points.
We fit ignore that third point. We fit add them. I mean, in the algorithm where I program, I consider that one too.
Okay.
You understand? Yeah. So, and the way to consider that one is to find the midpoint of this square at this point, somewhere in between here.
Mm-hmm.
So that point, we will calculate what will be your z level by taking the average of these four or these four numbers. You understand?
Okay.
So what will be the average? 50 plus 60 now 110 plus 65 175. Abi?
Mm-hmm.
Then plus 40 215. Abi? Then divide 215 by 4. What do you get? 54, Abi? So this place will be like 54. 54.
Approximately 54.
Approximately, yeah, something like close to 54, not exactly. So now what we can do is we can draw a line between this guy and here. A line between here and here. A line between here and here. A line between here and here. So we'll now consider these four lines. Come find which of them 955 they in between. So now, between 50 and 54, no 55. Between 40 and 12, no 55. But between 54 and 65, 55 day. That's not like 1/10 or 1/11 of that distance. So you go there somewhere here.
Yeah.
You can use another color. That's what I can change color. They call me. Okay,
so you could basically even get like 2 extra points.
So you can't get 1 extra point here.
I think you should even get 2 extra points.
Now 2 extra points you get. Now 4 points you get inside one this thing. So we can't get another one here. So the line will come. So the line we will get now can become 3 lines. So we'll get this line from here to here. All right. Another line between these 2 points. Then another one from here to this guy.
But now on the same line then they now.
No, we just did lucky say they look like they're on the same line here. If you go on the same line.
Okay.
The thing if you curve like this, if you go like this, depending on.
Okay. I get it.
You understand? So by doing this, if you get the main behavior within this. Do you understand? So
yeah.
the easiest way now, the shortest cut now to just not to consider that center. You can just join this guy with straight line.
Okay,
you get that?
Then we assume say the distance not too plenty, so.
So the result will still look great anyway. Go still look up close to that other one.
Overkill in the other one.
Not be overkill, but now that one are the standard way of doing this, sha. So.
But you don't get that time, okay?
No, that's the way I program the one we'll get for Sabak.
Okay. Sorry, Latif, I think I drop this thing for kitchen and wash my hands. Yeah.
Okay. Hello, phone lady. Okay. Wà á kí n lò láti jẹun. Atẹ́gùn yẹn ó máa pọ̀ jù. Ó ká atẹ́gùn kan fẹ́ ti pọ̀. Alpha, I don't come back. Okay.
All right, that's all.
ọṣẹ náà máa ń pò sínú ẹ̀ kò ń ṣe big deal. ọṣẹ kọ́kọ́ fún ọmọdé ó lè mú.
I don't come out.
Okay, I know.
Wow.
Ìwọ ni wàrà wàá dẹ̀ gba òṣèlú láti inú ṣíbi lọ́ṣẹ́ ńlẹ̀ ni. Ṣé o mọ̀ pọ̀ ṣe la máa fi ṣe la máa ń ṣe kékeré la? Màá fi kàn wait. Ṣé ó gbọ́ Yorùbá ni? Kò gbọ́ Yorùbá. Olódò ni ẹ. Ibo ló ti wá? Ṣáà fún un. Go. Ahmed, abeg, give me 5 minutes at the come.
Okay.
So, make we just go through one example with MATLAB quickly.
Okay.
So that make you just get the idea of what I talk. So, okay, this one's still calculates. So we go write our own algorithm for contour. You understand?
Yeah.
Then we go add them for this this your list of your this thing there. This is your folder. So
Okay.
make I call them Ahmed contour. So we go dey think am together. You go dey tell me how we do am.
Okay.
So now we get luck. Say we actually get a lot of this thing. We get a lot of function we don't create. We could make writing a contour dey very easy. So, but let us see. So let's say they give us the x, the y, the z. So now I won't use the standard. So this is a z level. This is not the contour level we're interested in.
Mm.
So now we go now go through. I mean all the this thing, the rectangles we will get for this thing. So let us find the size of the size will be the same. The x, the y, the z will get the same size. You understand me?
Yeah, of course.
All right. So let us now go through all of them. So let's see. Okay, let's get the size first. So we're gonna get the size, all right? So which means the number of rectangles within there will be m minus 1 times n minus 1. You agree with me?
M minus 1,000. Yeah, yeah. But why not M times N?
You know, if this x now 5 by 5, that means now 16 rectangles the inside. For example, we could use these diagrams why they use for here. Just so you go see what I talk. Make I cut one. Okay, so and I don't know where I fit zoom this. Yeah. Okay, so let's say,
Now 16 actually.
for example, I get say I was given these points. Make I just mark the points.
I don't see them. I don't write them for paper.
Okay, you don't understand why I be like that, Abi?
Yeah.
Okay.
But the formula gone mo try that too. But mo ti release document just 16.
You could just subtract one from the number of column, number of row, multiply them together now.
Okay, since you're joining these guys together and all that. Okay, that's true, sure. Not true,
So you
not
don't
true.
finish. Okay. All right.
Mm.
Can't use my energy. I can't try to.
All right.
All right.
Okay.
So let me go back to the math lab. All right. So now we now want to calculate and find the level. You understand? So we just say for m equal to 1 to m minus 1, and then for n equal to 1 to n minus 1. All right. So and so we'll do our calculation here. You understand? So the first thing I would like make we do now, we could just calculate all the points. I mean, forget about the schedule. We just calculate all the points. We could do all the contour. We could plot. We see whether we get something with reasonable.
Okay.
So what we could do? So as we enter inside each rectangle, we go try go through all the edges of that rectangle. I mean, all the vertices. We know the vertices within for that rectangle. So we'll try see whether like I mean, we will try see whether the z level pass through that rectangle. If you pass through that rectangle, so we'll calculate the points when you take out the size of that rectangle. Then we'll store that point. You understand? So we'll come plot them later. So we'll just say the points. So make I just say points here. All right. So here we now say so let's just say PT is equal to so we'll go through the sides in order. So the way we arrange this, we could just arrange them here like this. We'll just say so we'll get our M, then the N. All right. Then we'll get M plus 1, then N. Then M plus 1 will still be there. Then N plus 1. Then we'll go back to M, then M plus 1. Then the last one will be, sorry. I don't know what I did answer I do here. Okay, then the last one we can get M and N. So here now 5, this thing will get, these are, maybe I just call it that indices. Yes. So now, as I did like that, I want to go between the rectangle, like as like go from M to, as in, I did between now M and M plus 1. So also between N and N plus 1. So I want to arrange them in order around the rectangle. So let's say, let me go back to this guy so that I can understand this line. Why I write this one so that I go do it for me to just to go through this thing, the code. I mean, so just I go do sure say I check all the sides where they involved. So let's do this. Fidel they give one this thing for they give talk for this thing for SPE.
Fidel.
Uh,
I don't know about that one. No. Let me just message you now about that one.
when you post time for this thing, they teach something on numerical method for scientists and engineers.
Okay. You post now for status.
No, for apply maths for WhatsApp.
Okay, may I check? Okay. Okay, that's yeah. Okay, they asked to be George Iwo. Now, I won't Pringle guy like that.
Didn't sound
Section
familiar. It sound like one of my classmates back in Fudu. So we'll get one George Iwo for my set. Okay. So see what I talk. Make I see what I feel use Excel. Just explain. You see, if these points, you see where my cursor dey for my Excel sheet.
Yeah.
If these points now points, let's say 6 4. Shey you dey feel me? Like this
I
point na
see.
point 6 4. The next one go be 6 5.
Mm-hmm.
Then this one here go be 7 5.
7 5.
And this one go be 7 4.
Mm.
So now we say I dey do exactly with that here. Make I okay, I no fit bring MATLAB and this together. So here na 6 4, which is the M and the N. Then the next point here na 6 5, which is I keep the M, I increase the N.
Okay.
Then here now, so the N remain that same +1, and then the M now goes to +1. So
M
like
plus
that.
one
So
continue.
that way right time, it go make me go around this thing in a circle to go around
Cyclical
that
manner.
order. So now what's I do for that, please? So that's it. So with this arrangement now, I'll fit just pick them like that easily, just to do what I want to do. So that's that. Now what's I do? So Mn, I increase M, I keep N constant. You understand? Then later the M remain the way it did, then I increase the N. Then now the M go down, the N still there. Then
Come
the N
return
can
back
go
to
down
the
to come
same
return back to
position.
this exactly. Yeah. So that's what happened there. So with this now, all right. So I can index the X and then the M for each of the points. You understand? So I'll now go say okay, I'll now bring another counter. I equal to 1 to 4. You understand me now? Because I have 4 points there around this thing now. So I now do this one by one. So I now say so x1 points x1 equal to, I don't even need, I just do z1 and z2 first. So I'll just say for the first one, I'll just say the z1 equal to, all right, index I, comma, all right. So 1, I'll pass this guy into the z. Say z, this bracket, 2. So the first, another thing I can say my j equal to I plus 1. So I'll use j for 2. So now I go take know whether this thing passing through between them. That means that is z1 and z2. One must be less than z
Like,
level.
wait, you go too fast. This is Z1 and Z2. You take the. I try understand what
Okay,
you're
so what are
doing
you
here.
doing? I try get, like, make I just show this diagram again. You see that mesh why they created? So I pick any two line around the square or the rectangle. So now there are z values. Now I pick come outside too. So I go need to consider these z values with this z level to check if one day below this z level, one day ahead. That's why I bring this guy out. You understand? So this I, they refer, if this I they points to this guy, the J they points to this guy. You understand? So just so that if you go around that, this and that. Sure, you understand? So the I1 now this guy, then I2 now this guy. So
But if I
J1
turn
now this
4,
guy.
J go turn one. Wait, I come.
Uh,
1, 2, 3.
J go be 5 now.
You go turn 5.
So if I na 4, that is the last, this guy here. J go be 5, which is this guy, which is the same thing as the first guy.
Okay.
You know, that's why I put that first guy there. Sure, you understand
Okay.
that pattern. So now I
Yeah,
can
yeah.
check, say if you know how they check whether two things fall on either side now. See z1 minus z level times z2 minus z level is less than 0. That is if it's negative. All right. So that means one of them is higher, one of them is lower. So I will now do the calculation for the points. She understand? And you know how to calculate I do the calculation for the points. I go try find I'll just find the factor, use that factor, interpolate between the x and the y for that point. So what I could just do is see, I'll just extract the x and the y, the x and the y. Yeah, I mean you understand the x and the y too. So once I enter there, I'll just come and say, okay, let me extract the x. I never write contour code from MATLAB before. I feel like it's not, so but anything I do for C# for MATLAB, they do easier. And, so I don't extract the x and the y. So my next tag there, this thing I have to interpolate between them. So the points will just be, so I'll calculate the factor where I want to use. So I'll prefer to go between from 1 to z2. So I'll just say z level minus z1 divided by z2 minus z1. All right. So that means the x of the points that I want to calculate will now be x1 plus f times x2 minus x1. And the y, you get the reasoning, Abby. X2 plus is now
Y.
1. Right? So, but we know what in the z will be. What's going to be the z?
Now that's Z level we don't give us now.
Oh, guy, you're too good, man. Good, man. So, if we just make points, just keep them inside this. So, point equals to our point maker. Alright, so our x, our y, our z. And after we get down, we'll just add them inside points.
Point.
Okay? Alright?
Yeah.
Or, let's make I do again. Okay, we'll see what we will do here. Maybe we don't go need to do this. So, we just the calculate and they plot the points on the distance. We'll see how this thing look like. All right.
Okay.
We'll just see.
Tell me real time.
Plot x, y. So we'll see what I will get on. So we bring out one. We just find one standard problem from MATLAB with a popular area. MBD class. So make I see, make I browse for one problem. So we go put the XYZ then give them the level we want. They can calculate for us. So let's bring this, copy this problem to our MATLAB console. So we don't get problem we want to use. Now we go need to now. So this guy, all the values will fall between -1 and 1 now. So you know.
Yeah. Now sine and cosine.
Okay, so let's say I want to do contour for 0.5. For level is 0.5 now. So let's see 0.5.
Now, okay. Now come to it. No, the same thing.
You don't show anything. I don't know why. That one don't make sense. Make I use another one. We could use this one first. Okay, maybe they think click them as the number of, I see like the number of this thing what I want. You go make I get this thing. Okay. In the count that's the one as a number, so you know go show anything because so in this line they talk about the number of levels, but I won't give the
Okay.
actual value of that
Oh yeah,
level.
okay. Level.
So in
Okay.
that one, I'm going to send in a matrix, at least two numbers. So make I say, let's go back to the former one. We'll get. So let's say the contour. Okay, make I put 0.5 and then my is 0.2 and 0.5 so that you go get the message. Okay, so you don't draw them here. But the problem is we don't know which one is 0.2, which one is 0.5. Because now 2 I asked for this now and they come. Make I ask for 3 first, make I see 0.7. So additional one come, but we no see 0.2. So maybe 0.2 no dey. I don't know. Let's see. 0.2 supposed to that since you go from -1 to 1. Abi?
Oh, yeah. Why would they get many this thing? Because I dey see many different contours, but now three.
Now 2 colors there. I mean, how many colors you dey see?
Now three colors I dey see. Oh.
Okay, sorry. Me I dey see 2 colors now because of my screen. That's why I dey find because it's supposed to be 3 colors. So I dey see 2. I probably wonder why it's now only 2. Okay,
Now
so
three dey there.
now 3 colors are there. Okay, let me change my screen to this so that I go fit see all the color. I dey use this thing blue light filter because of night so that I go fit dey sleep well.
Okay. Yeah, sorry. Now why you know they see the blue?
Okay, now okay if I use blue and green, abi.
Mm.
Okay, blue and green go appear as the same to me now.
Yeah.
Make I off am. I don't off this thing. Sorry, MATLAB. Okay, yellow, green, blue. Now yellow, green, and then one other this thing.
Yeah.
Okay, all right. Okay. So what we go do now? Say we go pass this thing through our algorithm. We go see what our algorithm they will bring out.
Okay.
So at least that one will give us confidence whether we do rubbish or we do it to make sense. So let's say Ahmed contour. No more come at this point since we come out through error at the end of the day. So yes, usually this one. We could do only 0.5.
Okay.
Okay, sorry. I suppose to add hold on. You understand? Come on, look,
Even for inside your distance code, where would they put plots, those stars, what do you think?
No hold on, no need for that. Once I don't do one hold on outside here.
Okay, go effect.
Yeah, you go hold on throughout. So let's see whether you could get
okay.
Gas. You see how?
Okay. Yeah. That's
You see how you just get them, ma'am. Now that one be that is 0.5.
Yeah.
So
Yeah.
more add another, more add that of 0.7.
Yeah. Yeah. Wait.
Gas. Okay. That one is sign. So that one with the outside now be 0.2.
Yeah.
That the phone. It's not with me now, it's with you. Where did you keep it? You threw it away. I mean, buy me flash phone, me, this phone, you know. So you see, say this one, we don't use the inside. We not use the inside of that square, just the outside.
Yeah. And the result is still.
Okay. So it's said to draw contour, no be a big deal. Just one. Other than they say, they do computational geometry, you could say they do one big thing.
A big thing. You think it's easy to calculate for polygon?
No, that one hard. We just if you come out that one, the rest simple. So it's fine. All right. You get the thing as well. So.
Another point, we just join them with straight lines.
Yes, but now where the thing they difficult now the schedule. So let us ask this one now. Be say they don't give us somebody don't plot the contour for us. We just locate the point. Let's say they don't plot the contour. So one calculates, one can locate the point. So as in like join them together ourselves. So how good one? That now where the thing they challenging. So let us see how I implement that. You understand? So we'll try to do something like that here. So but if we just collect all these points, can't they plot them? Now rubbish we will get.
Of course.
Because we don't get the right schedule, so we have to know what the schedule is. So for a start.
I don't understand though. If we get all the points.
If we collect all the points, just plot them, now rubbish we go plot them.
Okay, without all this code we will write for here, now what think they try to talk?
No, with this code we will get with this code we will get here like this. If we just plot an rubbish we go plot. Like for example, the original contour with the for the background, I'm MATLAB get them.
Yeah, I know.
We just calculate points on that contour. So we don't know the schedule, how the line is supposed to go.
Oh, I understand what you talk about. Okay, not true, not true. Because can't be a Rikini and Ben, any more, boya, okay, not true.
Okay, for example, Moko try.
I get what you
Moko call that XC and then YC. All right, so let's just collect all those points, all right, and then plot it and see how it looks like. So here we will collect the points. XC equals to XC. All right, then YC equals to so if I now come here and see plot. So let's go back. Let's now see do this. Ahmed, you still try to talk? No, we even get luck. This one even fine. So at least if you see the idea, if you get the idea, see how the thing will look like. You understand? So now we now need to have an idea. So one of the first things I first calculate. So now this now so I will need to now find a way to join the distance together. So within each, so the way I consider this guy within each as in for each m and each n like this now, as I can consider this 1 to 4, I will get 2 points at least. That is, if there's anything um within that particular what's that column square, or what's that column, anything I column within the rectangle. So I'll get at least 2 points. I'll get 2 points. We go show me. We will give me one line. So the best thing we go do now, we could just say, okay, let us be collecting all the lines, and then be keeping them somewhere. And then later, after this thing, we'll now go through all of them and find the lines that are joined together. All right. So and then join them.
Yeah.
Okay. So now let's see how we do that. So we get the function where they calculate the distance of 2 points, Abi.
Yeah.
So we should use them for like, if you know, use them. So, but let's just think about the idea. The idea is simple. To just find the norm of the difference between any 2 points we'll get. Okay. Yeah. So I made that far.
Okay. Yeah, I did.
Okay. So now let us now think of a way of collecting the lines and then joining them together. So we are dealing with only one level anyway. So we can just collect all the lines. So um, within each of these guys, we have a line. So let me just say
Okay,
line
one quick
equal to
question. If we have two levels now, if we have like several Z levels, then we have
uh,
an external for loop here. We
exactly.
will need
Now we
to.
will now go through all the levels one by one.
Okay.
Yeah, you are good, man. Let me make my life easy. So let's now see. So here I'm not saying okay. Uh, line equal to. So I'll say line. Then I'll now say x y. So then here, make I keep this guy outside. Make I call him lines. So as I collect all this line, you understand, for each of this guy. So for this, after this succeed guy, so after this for loop here, I'll come here. I'll say lines equal to lines. This one I think make let me see. Because meji. Okay, mole take in the third dimension. So go cast 3. Understand? So I'll just say cast 3. So lines line. Yes, ma'am. Mo mú láti ta kílódé. Má bínú mi sí fọ kílódé. Okay, so cat 3. So let's see what I buy. So now, so after I don't collect this guy, now I'm not come outside now. Now I want to join them together.
Okay.
So let's say function join. So this guy will return curves. So equal to join these guys. So I will send the lines here. So now, so they look this thing now. If you get another idea of how I should do this thing, you should tell me, sure. But this I just like show good. I just take you through what I do, how I do, sure. So now I get all the lines. So if I run this code here now, this guy go there in 3 dimensions. So each matrix where I get will be 2 by 2, which is actually each of them is giving me a line, a line, a line. So now as I come here now, I'll now pick yellow. Yeah, good. Yeah, it's yellow. Yeah. It's yellow. Yeah, color yellow is good. Go. Don't worry. So here now, I will collect this. I'll now say, okay, maybe equal to, I want cells. So I'll put a matrix inside each of them. So we'll say while why the third dimension of this guy, why size this guy 3, the third dimension is greater than 0. Go and play to Malim. Go and play to Malim. Hello?
Mm-hmm.
Okay, now you don't say I collect this thing, I concatenate this guy in the third dimension. So I check that size, why that side is still greater, why it's still greater than 0. So now that's what I want to use. So why I use that? Now so I how they know the number of lines we see inside these lines, because I could come out anyone why I don't use, I will come out.
Okay.
So yeah, so to start with, so now we'll now create say a curve. So you could do like this. So I could take the first line. So which is the first this thing of this guy. So I don't take that guy. So now I'll now begin go through. I mean the rest this way. So let me just say. So I'll go to sideline 3. So now see I take the first line, I put them inside this curve, then I can't delete that line from this list. So I enter here now. So I want to go through all this line and I find which of the line within inside here they join to this curve. Now what I want to find out, so which of the line within here they join to this curve. Now see the idea here. How I go know whether this line did join to the curve? That means say the either the beginning of this curve go match with the beginning of this line, or the beginning of this curve match with the end, or the end of this curve match with the beginning of this line, or the end match with the end of the line. You know what I talk now? So I don't pick one line now inside this line 3. So now I go check whether they match anywhere. So anywhere where they match, it will determine. I dey come. Hello?
Okay.
A fellow disconnect the internet one. Yeah. Go and meet your mommy. Go and meet your mommy. So now how to do that now is I get one function where I write for C# why they call find. So function find. So this function I dey send the curve and the list of lines. So which is actually different from the way I'm trying to do it here. But let me just do everything inside that place, inside this place here. So I don't bring this line now. So I now check the curve. I check curve. Okay. I can say if norm curve. So I'll take 1. That is the first point minus line 1. All right. That is the norm is equal to 0. That means those ones they join together. If this and this, that means they're the same. All right. Ahmed, no dey there again.
Are they here? But I just revision this first system there.
Which line? Which number?
This curve line 31. Curve
Okay.
1, which in the inside? Which in be this thing?
This curve I seen dey like this now. Now because it start from the beginning, so now one line the inside. Note I just extract one line, put inside. So now they check whether the beginning of that curve and the beginning of this. Now I can't enter inside the loop. Can't they pick each line within inside these lines now one by one. They compare them with the curve. If the beginning, because the beginning are 1 1 now. If the beginning match, now you see that the two join together. So I go take the end of this line, add them to the top of the curve. Now this I want to do. So if this happens, so I go say then curve equal to line line end. All right. So the curve would be under like this. They said that so I add the line on top. So then I'll check else if so I'll check if now the end. So if now the end of the curve join with the top of line one, if now end of the curve join with the top of line one, I go add the end of line one under the curve. So that is I go do like this. Say okay, it should be this way. So the curve would be here. All right. So another case, I'll consider the third case. So the third case will be say if now the first one I consider now first of the end, first of curve and the end of curve. Now which I consider now. Now I consider this guy first of curve and end of one. So if now end of one now in join together, that means say now the first of one I go add. So here will be one. So then the last case will now be, so I think just call this guy else. You know what I mean? No, nobody else. Just else if in case also because else you know they. So this guy now end. So this guy else if this end. So let me not make sure, let me be sure that I don't make mistake. I didn't make mistake here. So this guy, if curve one minus end. So because now one, so this guy go day on top. So I mistake there. So then if curve one and end, because curve end, so this is fine. So you go do like this. So if I go through, so for n equal to one to this guy, so if I go through from this guy like this now till the end, I go don't add all the this thing way dey inside that. So as I dey add all of them, as I dey go like this now, I suppose they. So now, okay, so anyone where I add, so anyone where I add, as I add them, as I don't add this line now, so I suppose delete them from this guy. This one be a little challenging to manage for you.
Wait, if you add line, you go delete them, right?
Because I don't add them to the curve, to this curve, so I suppose delete them, then break, then I'll go through the thing again. So if I go through everything from beginning to the end here, and I no break, so now me say that curve no get anything where I want add again. You understand? If I go through everything and I no break at any particular point, that means I suppose break out of
For loop.
no while loop now.
If you break from here now,
Ahmed, did you?
Yeah, I get you.
So I dey try think so let's say I to write them down that where I been wan write them before. So to combine them here go dey a little challenging. So to break them down so that because now 3-4 loop, another 4 loop dey here outside. So make I do this thing here. Make I return the point where I go add and information about how I go add them. So so function. So like this. So what I say will be found. So add points. Equal to find see lengths. So I just say curve length. So I go we do this say so I go through this guy. I go through this guy. So here now I go now return okay yeah, make I done like that, make I done like this. So I go now return so okay. So this now where I see the thing. So then the points where I want add. All right. So I will say the points where I want so that now add points. Go to this guy. So then I go now see you get another thing where I need to do. I need to add found. So ordinarily found will be 0 once I enter here. So but if now this first case now it work, so I go set found to be 1. So if now here I go set that to be 2. So I just know where they take join. Now they join. Okay, make I not disturb myself. Make I just be this specific because if the first two head now the this thing match the head of this, so I go add this guy to the top. So and if they add to the top, I they call am 1. So if I they add to the lower side, I call am 2. So here they add to the top, so this guy should be 1 and this guy should be 2. So this found will be either 1 or 2, and then go give the points and go give the remaining line. So I go now, I feel delete. Okay, so anytime I don't find 0, so I just come here. I just do like this now. I'll say okay, that this guy equal to this. All right. So now, so if not found, if not found, I didn't see anyone. All right. So and the size of the line still greater than 0. I go store the curve where I get, start a new curve. So in this case, I store the curve and then I say curves equals this time as this guy. So then start a new one. Curve equal to, and then delete that guy from there. Else, if it was found, I could just follow this, and I will just say okay. I'll say okay. So if found equal to 1, and let's say I go add that for the top. So I'll say curve to, sorry, add points. Then else, which is the second piece, we'll say curve equal to points. I get curves. So I'll get curves. Okay. Hello.
Okay.
Okay. So make I explain what's in the go on here again. Sure time. Because last the code don't finish now.
Okay, explain.
Wait first. Wait.
Why did you write the code? I don't know you had it those.
Hey, il est dit pele. This 12, now 12 we to 12 a.m. So pass. You supposed to sleep. No vex. Why just run this code? Make we just see whether it work. Then tomorrow, show me here. They will now. We'll just check. We'll see what I work. Then tomorrow we now. Yeah, we'll now see.
Let me hail your wife.
She dey greet you.
Let me hail
Ahmed thinking here. So for I equal to 1 to numel curves. So what is this again? Plot. Sorry, Jare Pele. What's it? Or make I just release you then if I fix this thing then. So let's see. Let just try see whether it makes sense. Think about correct to create on my machine.
Okay.
Cast 3. Dimension are even not consistent. Let's see. That's line 21. Okay. So look, I see this guy DMT. This guy 0, 0. Okay. To the ability just 0. Ilé wa empty 0. Ilé 0. So time to match just 0 no mama that. So make us see if numel line is greater than 0. Alright. Then go to this guy. Then I end. Okay, no calculator. So I get 8 skinny lórí mi báyìí. 2 by 2 by 8. Ilé strange. Oh, sorry, mo ṣe mistake. Mi wọ́n fọkàn. Mi n kó gbọ́ ẹ̀tàn. Inú bíbá ẹ̀kọ́ rẹ̀ kí lè wà ibi tàbí lè ẹ̀kọ́ wa. Okay, so yeah, 632 lines. So tí n bá pé kó wá join curve, so mi tó ti máa join ní so wá bíbá yẹn sìn. So let me see. So the first curve, so just these guys. Surely Katoni, just these 2 points. So now Timati wa wo bíbá yẹn sìn. I'm on my run, so let me see the first thing. So ìgbà tí mo wo bíbá yẹn, the original 632 ni original kini. So ní ìgbà mo ti yọ ẹ̀kan kúrò níbẹ̀. So nígbà tó ti lọ fún found, tó ti lọ wá curve tó bá join mọ́ line yẹn. So ó jáde bíbá yìí pẹ̀lú 2. That is it. This is the information about this mark connect up. Then points in fair add yẹn, ó mú yẹn náà wá. Then the number of lines also reduced because you're concurrent so 630 locals. So which I go through here on my dreams online, I'm a connect and curves. So now my join if it's more today and by. So see your body can but most times if by the mama so let us find out what is happening here. So the curve yet the meta.
Okay.
So again. What's the marrying? So it's just unconnect to one. So like that. So unconnect to one. So to buy my will by. So let me see where I lay my work. So after argument add points may other not assigned. So it become article T assign. So stick over there assign. Find the no. Oh yeah, find the no wrong. So tí o bá assign kò yẹ kí o rí find. Okay, let me just be getting explicit by way. Else if equal to 2. So that's going to law. If there's a mistake, you really imagine. You see, they get the same problem. So what I go do be say for each case, to what day by manipu kuma write the found value theta so that came to shell display found. So that will know what happened the last one to shell. Okay, and the last case, Tori found 1, but point was not assigned. How will the point not be assigned? Let me see what this is strange. For assign point C. Sorry, I did something do I do wrong here. End. One. Okay, you did correct. So when I use one here, I use end here one end. I use end here one. I use end here one. Okay, it's fine. And I set this guy to 0. Anyway, I can replicate this guy. So we ẹlẹ́kẹrin ni ó ṣe try 1, 2, 3, 1, 2, 3, 4, 5, 6. Ah, ibi tó ti ní problem yẹn 0 ní F now. So how come tó wà wọlé? Okay, ó true kí nítorí pé kò sí. Okay. Okay. Màá kàn set out point as nothing on. Okay. People need love anything, so never should. So to David Bayens, so then we'll size the curve here. Just 8 points. So I will add it to this guy. So and then create new one. So then go again. So to go that again. So this guy. So delete the image. Go to the meta. So that's today. Okay, so that's 55 by 2. It's a read. Bisha will be a read to 9 by 2. Continually. 7 by 2. 3 by 2. How many line open? Maybe 523. Should go. 2 by 2. Something is wrong. Okay, 10 by 2. Tomorrow, what general? 2 by 2. 44 by 2. 36 by 2. 69 by 2. 89. Okay. What's in button? Okay, that's fair. 284. 5 by 2. 26 by 2. 26. 30. Okay. 0. 190. 3. Again, I should go my share. Okay, she's up. So it's a little bit. So let us now see the plots. Okay. Okay, salary lórí. Okay. She leave her. So that my exposure. Okay, my correct. Okay, I'm correct. So this is what I got from one of them. I'm sorry. Okay. This is another one. So then come on, she okay. Oh, it really makes sense. Really what I expected. Try to arrange it. So let us see. The car plot so car plot lórí car generate ti MATLAB car plot ti wà lórí. It's MATLAB lórí. So car plot ti wà lórí. Each of them jẹ́ kí n máa kájẹ́ kó dark kó as in kó wà thick so that a máa lè mọ ibi tó wà. Yeah. Oh, sorry. I mean load on, sorry. Okay, so what's the plot you call? We'll show it to her. Can you see?
Yeah,
So let's look at another one. Okay, see this one. So another one. Okay. Another one. Another one. Okay, another one. Another one. Another one. Another one. So now we observe we will join our curves come. That like all this one like láti you ever seen supposed to be one continuous curve. But kò rí bẹ́ẹ̀. So do you know why? Why it should rí bẹ́ẹ̀? Eh? Do you know why no sound like that? We no fit join am as one curve.
Oh, well,
Okay.
I don't know.
This one, Don't worry. Nah, this thing, nah, the tolerance. I want this thing to be exactly zero. Timba lose small number, maybe 1 exponent minus 6. Eh? So my better. So my around
Okay.
so because literally if you check those curves, they actually join, but you don't see them and see them join. So tolerance in man, so let us find out. Let us try again. Hold on. So let us see. Here, okay, one particular maybe this one is even worse. Anyway,
Mm.
it's even worse than what I expect.
One shake, yeah.
So okay. This one is even worse. So whether the other ones go join, we look at same thing. Anyway, so yeah, there's supposed to be one small data in the why supposed use why they normally use to know the scale of the problem. So that na my delta x, delta y. So let me just so the x. Okay. Oh, sorry, now what are they use here? Sorry, this one is different. So say less than 706. That's what it's used. That's the one that I know more. Oh, see, okay, I'm in. Sorry, Adisheton. Ó ti ń sùn lọ, mo kàn fẹ́ sáré rush kìíní. A máa continue ẹ̀ lọ́la. Ahmed.
Huh?
Okay, sorry. Aha. You see, say you don't get that line complete. Now, mistake I make. The third one I no use am well. Now, less than supposed to, they still use equal to. Or the way you get the lay complete.
Yeah,
Okay, look at the other that. You see, I don't know.
Econo de lo shogun.
Yeah. So you see the next one. See the next one. See the next one. Next one. So basically, you know, I see we dey draw contour for Samako Center.
Okay.
So no worry. Tomorrow we'll review this one before we continue to the complex
I
pieces.
mean, if you me upload the video for YouTube, so before we even start the class, I will watch the video first.
Okay, all right, okay. No worry.
We watch them again.
I'll upload video on YouTube for instance.
All right, no, Allah. Thanks, man.
All right, okay.